All right, so I've shown you how to find the R value. Now we need to find the regression line. And the regression line is really just a line of best fit. Again, there's a super complicated formula in the book. We're not going to do it. I value technology and how to adapt to it. All right, so notice when we're doing this that the correlation coefficient, that's R, that sign is going to match the sign of the slope. And remember, we're doing linears only. So remember this, y equals mx plus b. This guy was the slope, and then this is the y-intercept. The sign of this slope is going to match the sign of the R value. Okay, for our calculator is going to use y equals ax plus b. But a is still the slope, and b is still the y-intercept. All right, and so what we're going to do is we're going to take our scatter plots, and then it's going to draw a line through them, and that pretty much is the best estimate that we can have to make predictions. We can only, it's important, can only make predictions if we've already done our hypothesis testing and it's significant. If it's not significant, we can't do anything about it. We can't make predictions, we can't find a line of best fit, we can't do anything. All right, and so to do the regression line, we're in statistics, and so you're going to push stat, then you're going to go to calculate, and you'll go down to number 4, which is linear regression, ax plus b, and then you'll press enter, and you'll make sure that the x value and the y value is where your information is. Normally we'll put it in list 1 and list 2, and then we'll press enter. All right, so let's put this together and find, a little more information. All right, when we're making predictions, it's linear. R is significant, so we've done the hypothesis testing. The randomness sample, the randomness sample. The sample is random. And those are the important, there's more, but those are the important aspects of it. All right, so here we are, same data as we were before, okay? And so we're going to go push that, go over to calculate, go down to number 4, and here we are, okay? And we get this information. And I'm just going to write it on the computer. C A equals -3, let's round. So all these are whole numbers, so I need to go down 1. And B is 102.4.9, so 5. All right, so that equation is y equals -3.6x plus 102.5. That's the equation. And so we can use that equation once we've established it's significant to predict things. And so we had y equals -3.6x plus 102.5. All right, and so we want 10 absences, and then absences is x. So I'm going to do -3.6 times 10 plus 102.5, and I'm going to estimate what my grade would be. All right, so I'm just going to type -3.6 parentheses 10 plus 102.5, just exactly as is. And so my grade would be a 66.5. All right, let's do the other way. Like, I want to be in the class. How many absences could I have? Okay, and so I'm going to do 80 equals -3.6x plus 102.5. And I need to solve that. So I'm going to subtract 102.5, subtract 102.5, 80 minus 102.5. I get -22.5 equals -3.x. Okay, and then I'm going to divide by this -3.6 divided by -3.6. and I get x equals 6.25. So you can miss about 6 1/4 days, 6.25 days. All right, and so, and this line is the line of best fit. It's the best estimate that we have for the data, and so it's not necessarily totally accurate, but look, it makes sense, right? So 80% is between these two numbers, so our answer should be between 6 and 8.25. This guy, we want 10 absences, and 10 absences falls between 9 and 12, so our answer should be between 58 and 74, and it is. So it makes logical sense. All right, let's do this guy. So a researcher wants to see if there's a relationship between the ages of the wealthiest people in the world and their net worth. A random sample of 10 were selected, and here's the data shown. Okay, so I'm going to go ahead and we're going to type that in list 1 and list 2. So I'm going to go to stat, enter and edit, and I'm going to type it in really quick. I hope you're doing it with me. All right, this should be 23 or 2.36. All right, so I've typed in all my data. We want to draw the scatter plot. All right, and so I need to make sure, like my window. So this basically goes from like 0 to 100. This guy goes the same thing, like 0 to 100. So I'm going to push window. It's right next to y equals. I'm going to go to 0 to 100, 0 to 100. All right, and then I'm going to push graph. Okay, and there it is. Kind of all over the place. All right, so maybe it's positive, maybe it's nothing. We're not sure. So to verify it, we're going to do the linear correlation. So we go to stat, go to calculate, number 4, make sure it's like my stuff is in L1 and L2, go down. All right, and so we get R equals 0.1. All right, that's close to 0. So there is no correlation between this, which makes sense, right? Like Taylor Swift, who's young, has a ton of more money, and I'm older than her. Like, it just makes sense. Okay, also, I can't. So, I mean, God thinks it's beautiful, but he's probably. Okay, so no correlation between the data. We don't even need to do hypothesis testing because it's so close to 0. So that means we can't do predictions, we can't do a line of best fit, we can't do anything else because there's no correlation. All right, let's do another one. Okay, now this is stuff for a rental car. And it's how many rentals they do for different companies and then their revenue. I'm going to type that in L1. I'm going to type it in L2. That, edit. I'm going to clear the list. And by clearing the list, I go highlight like the L1 part, and then I push clear, and it clears the whole list. Don't push delete. Push delete, I'm going to clear the whole list, and I don't know how to make another list. So then you would always be using, I don't know, L1 and L3, unless you want to do some Googling. Googling God, that's how we get through most of life. Okay, that's my secret to life. Anybody who asks, Googling God. Some really great friends. All right, so I typed it all in L1 and L2. Let's draw the scatter plot. Okay, this guy, yeah, it's from 0 to 100. This guy, we can change it to 0 to 20. If I don't, and I just keep 0 to 100, 0 to 100, this is still what I get. And so it's kind of like that. It goes in an up lane. If I want to double check, I can go change this maybe to 0 to 20, and I can see it better. It still goes up position. All right, determine the type relationship. So we think it's positive. And now let's compute linear correlation. All right, and so to do that, we're going to go to Stat, Calculate, number 4. And so I will get R equals 0.98. Hopefully you did too. Okay, if yours is a little bit off, that's fine. But if it's like 0.14 and I got 0.98, there's something wrong. All right, so we think this makes sense, right? So it goes up, and it would be a positive R, which means our slope should also be positive. I'm going to go ahead and write down, we got y equals ax b. I got a equals 0.11, b equals 0.40. I'm just going to write that down in case I need it later. So we're going to test alpha is 0.05. All right, so there are 1, 2, 3, 4, 5, 6. N is 6. That means the degrees of freedom is 4. All right, and I'm doing 0.05. For 0.05, I need to use the table I. It doesn't tell me. There we go. Table I and 4.05. So I get 0.811. 0.811. 0.811. We're here. All right, so R from table I got P equals 0.811. My R was 0.98. All right, we need to compare P and the absolute value of R. So P was 0.811. Absolute value of 0.98 is 0.98, and that one's bigger. And so when it's less than, we reject the hoe. Oh, get away from me. All right, we reject the hypothesis. Remember, our hypothesis is P equals 0, which means no correlation. Our null, P doesn't equal 0, which means there is a correlation. So if we reject the null, we're accepting the fact that there is not no correlation. So what we're really doing, is there's enough evidence to accept that there is a correlation. All right, and we happen to know that it is positive. All right, so that's putting everything that I've talked about in the last couple of videos together. All right, let's do another one. So I'm going to go to, actually, hang on one second. Just hang on one second. Yeah, I'm going to stop the video, and we'll do this problem, the next video.